So we will be recording this webinar. We'll be sending links out to everyone who registered for the webinar. And we'll also be putting a recording of this webinar on our YouTube channel, where you can see a lot of great content on HighByte and other webinars that we have produced. At this point, I'll also end this poll. Seems like most people have done it. I'll share the results quickly. So looks like there's a number of people that are researching, gathering information. That's excellent. Some people are well along their way, and then we've got some partners and customers who are joining us. So exciting, a wide variety of people joining us. I'll stop sharing and we'll get started. So first of all, I want to welcome everyone to this webinar. I want to thank you for joining us. You know, we haven't done a webinar in a couple of months now, so we're excited to do that. I'm John Harrington. I'm the Chief Business Officer at HighByte. I'm joined by Aaron Simile, who's our Chief Technology Officer. I'll throw myself on video for the presentation portion. If anyone has any questions or concerns or issues as we go through this webinar, please use the chat and for issues, or use the Q&A for any questions that you need us to answer about the content that you're seeing. We'll get started here. This is just a quick view on the agenda. We've got a little bit of background on HighByte. For those of you who are not familiar with HighByte, we also are going to talk briefly about data ops and analytics, and then we're going to jump into a demo. And the majority of our time is really around the demo. And we're excited about all the new technology that we've got in this new version of the HighByte Intelligence Hub version 2.2. So we want to spend the majority of the time there to show you that capabilities. So exciting about that, and want to spend most of our time with the technology. And then at the end, we'll be able to take questions. So any questions that you have, feel free to add them. And we look forward to having more of a dialogue at the end. So really brief, little bit about HighByte. HighByte is a software company. We're based in Portland, Maine in the United States. We're focused on software for the industrial world, for companies, industrial companies that are going through Industry 4.0 or digital transformation, and really providing a data ops solution. Our software has been deployed across a wide range of manufacturing companies to date, many different subverticals: food and beverage, pharmaceutical, pulp and paper, mining and metals, so wide range. We also have a set of partners that span the globe. So we look forward to working with companies all over the globe who are interested in data ops, interested in progressing their data infrastructure as they move into a digital world. So our solution is the HighByte Intelligence Hub. And the HighByte Intelligence Hub takes a new approach to data integration in the industrial space. So instead of moving data up the Purdue model, the stack of applications, this is taking a hub and spoke approach to moving data. So the Intelligence Hub makes connections to many different systems, both on the IT side and the OT side, and we ingest this data. But what's really unique about it is we have the ability to model and structure that data. So at the core of the solution is a modeling engine. You create logical models based on however you want to use the data, so asset models or product models. And then you push the data back out via flows on some time or event basis to the applications that need access to that data. This is a completely codeless environment, so you don't need to know how to write REST APIs and how to connect to OPC. It's all done through a web-based user interface, and you're able to ingest this data and work with it, model it up, and send it back out. So very efficient, and really spans that OT to IT gap. as you can see over the years, for those of you who've been with us and are familiar with us over the number of years, this diagram keeps growing. And the biggest thing that we added in this past release was this time series component and historians. So that's really what we're going to talk about today. But as we get into time series data and process historians are used widely in the batch and process manufacturing space. And analytics is really the panacea of Industry 4.0 and digital transformation. So it's the driver of the value behind all of these projects, is being able to analyze vast data sets so that we can drive knowledge across our entire corporation and enterprise, and then improve our operations. But what we see is, if we dive into it, there's this disconnect between process historians and analytics in terms of the structure. So if we look at analytics, they generally need a contextualized data set that's understandable by the data scientists and the business analysts. So a lot of times this data is being used by people outside of the OT environment. At the same time, on the process historian side, which is this vast amount of data that's available for analysis, it was really put together for process control. And it has limited context because it's really just focused on process control data. So it doesn't know as much often about the quality, or it doesn't have access to the asset maintenance records. It has access to what is going on with regards to process control information. So there's this data imbalance there, or difference. We also see that on the analytics side, they often want tabular data. So they want like a table of data, very consistently built, either based on a time cycle or on an event, depending on what you're analyzing. On the other hand, a process historian takes in massive amounts of data at a very high rate. So it uses a structure called a time series database to store that data, but it's not in a tabular format. Now, on the analytics side, we see that you need to be very agile. You generally iterate through your models and through the data till you come to a data set that you need, and then you start running that at high rates. On the historian side, these tend to be very stable, validated structures. You don't want to be changing your historians. You don't want to be making adjustments every other day based on how people want to look at the data. You want it very stable and consistent. And then on the analytics side, we're looking at both historical data for our learning, and we need streaming data for the real-time analytics. Unfortunately, on the process historian side, that's what we've got, which is awesome. It's tremendous. We've got that real-time data, and we've got the historical data. So we just need access to it. But there's this structural difference between the two systems that we really need to overcome. And this is where a number of companies that we've talked to have really struggled. And this is where the HighByte Intelligence Hub comes in, and that's what we're going to show you today, is how we can overcome these structural differences to provide a highly agile data set that's built just for the analytics, but leveraging that process historian data. So the big technology that we added into this release, this 2.2 release, is connection to Pi, connection to the Pi data archive. And as you can see here, we have bidirectional connection. So on the top diagram, you can see that we can pull data out, either Pi points, Pi assets, or event frames, pull them into HighByte, massage that data, merge it with other systems, standardize, structure it, and then publish it out. We can publish it to a CSV file. If you want to pull a whole year's worth of data, dump it into a file that you're then going to use for learning in your analytic, a lot of people want to use CSV to move that data. At the same time, if you need streaming data, we can stream it directly into the cloud, into your data lake, or directly into the analytic. So we're making this whole process very streamlined and very simple. At the same time, we also have the ability to take data that HighByte has access to through all of its other connectors and publish them into Pi. So where some of our customers are using this is maybe they've got some sensors that produce MQTT data, they need to contextualize it, standardize it, publish it into Pi assets or Pi points. We can do that as well. Pi isn't the only feature that we added in 2.2, but it is definitely one of the headliners. So we added Pi, we added InfluxDB as a connector to InfluxDB to really simplify the connection. We've been using our REST API and we realized that we could really simplify that. So now we can push data into InfluxDB. We also can push data to a CSV file, and we added a connector to Oracle. So lots of new connectors in this release, in this 2.2 release. We also added connectivity via SAML to third-party identity providers. So if you need access to leverage like Active Directory and others. In fact, I have one more poll here that I'm going to put up, and that is about identity providers. I'll launch that. So in this poll, we're just asking, what are you using identity providers? Are you using Ping or Active Directory? Those are the ones that we hear about the most. Are you using others? And certainly if you're using others, we'd love to hear what those are. If you could put it in the chat, or we can reach out to you after. But we're very interested in making sure that HiByte can be integrated into these identity providers, and we're able to secure the system. And then, as you can see, I'll end this poll. I'll share the results real quick. So Active Directory, as we expected, by far the widest used. Ping identity is also used. Some people not quite sure, but great. So thank you for that feedback. That was great feedback for us. So in terms of 2.2, we have a number of other features. And at this point, I'm going to turn the presentation over to Aaron, who's going to take over and do the demonstration. Aaron, you should be able to take control now.
Let's jump into it. Let me know when you can see.
You're a little bit muted on the volume.
Oh, we're locked and loaded. There you go. Doesn't work when the mic's up in your head.
That's it. I can see it. Good luck.
So we're in our new space. If you remember in the old space, I had HiByte over my right shoulder. So I try to do the same thing here. We have a bigger team, so I'm hiding away so I don't interrupt them. I had to write that backwards, which took about 25 minutes, which consequently is about what the demo will take. So let's jump into it. So I'm going to show you a lot around Pi, and I'm going to show you some of the use cases and new features. So I've got a fresh, as in all the webinars, completely fresh install of HiByte on my system. So I'm going to build everything from scratch. So the first thing I'm going to do is connect to Pi, right? And the way we do that, I'm going to launch and John, can you see this okay? Can you just confirm?
Yes. Yep.
All right. So this is a Amazon EC2 instance that I've installed all the Pi server on, right? And what we do to connect to Pi is there's a third-party component called the Asset Framework SDK, which is kind of, if you're familiar with Pi, it's their standard way to connect into the Pi system. So that needs to be installed on a Windows system. And then what we provide is this, what we call the OSIsoft agent. And when you download it from the website, it'll look, and unzip it, it'll look like this. Let's just open it up. And so what you'll see in here is there's an executable. As long as this is running on the Asset Framework SDK, is installed in the same system, it'll connect into Pi. I happen to have everything installed in the same box, but that could be distributed. And then you run this executable. If you on the user guide on the website, it'll show you how to set it up. It's pretty easy. In my case, I have it installed as a Windows service, and that's in the user guide as well. So this will launch. It'll connect into Pi, and then it'll listen on a port, and we'll see on the HiByte side how that works. All right. So I'm going to create an OSIsoft connection, and you'll see now that we've got that in our connection list. So what it takes is an IP address. That's the IP address of the VM that I'm running up in AWS. And then this port, that's the default port I'm going to connect in on. So we just need to make sure that port is open. It's going to make a secure connection. And then there's also a token that you set on the agent side to just authenticate. So in this case, I've already set that up. Again, that's in the user guide. So once I submit that, what we're going to do first is we're going to go browse. And if I've done my job right, just give this a second. On the browse, what it's going to show is the databases in Asset Framework. So in this case, I have a HiByte database. I can start to drill into that. I've got a test project from OSIsoft in here. And I'm going to bring in B210. And from this point on, I'm going to call this the B210 demo, because everything's going to be kind of around this, this boiler asset in Pi. So I'm just going to rename it B210. I'm going to save that. And if I do a read, what you'll see in the right panel here is the element name. So I'm reading the asset out of the asset framework, and this is the name value pairs from that asset. So just to put some context around that, if we jumped into the Pi instance and looked at their asset explorer, right, you see that same hierarchy that I just traversed. You see that asset, and then in here, what you'll see is the same name value pair. Some of these are tied to simulated tags in Pi. Some of these are just static values. So that's pretty cool, right? But let's do something even cooler. Let me trying to hide the webinar stuff because I'm working on one screen. All right, so what I actually want to do, let's say I want to read all of the boilers. So that this asset is based off a boiler template in Pi. So I'm going to create an input called boilers. It's an asset read. The database, as we saw before, was HiByte. Oops, if I can get the spelling right. And then the query, what we do for queries is we support the the Pi syntax, right? So there's a syntax that says template boiler. And what this is going to do when I do the read is it's going to read all of the assets in Pi based off the boiler template are going to come through. So what you'll see in JSON here, and this will make more sense in a minute, is an array of all of the boilers, not just the B210, right? So that was pretty easy. So what do I want to do with that? First, let's say I want to dump that to a SQL server because I want to use something like Tableau to visualize it, right? So what I'm going to do is create a SQL connection. We won't be able to get into all the details, but MS SQL, I want to show you kind of the power of how quickly you can do this stuff, which is pretty cool. So I've got a local SQL server on my box. Oops. I'm going to connect that with default settings. The database name is test. Username is Aaron. Super secret password. Chrome's yelling at me. So I'm going to just create an input real quick to make sure that connection works. You can see I've got some tables in there. But what I really want to do is create an output. So I'm going to call this boilers, and I'm going to drop it to a new table called boilers. And instead of just doing an insert, I'm going to do, and this was added in the previous release, an upsert. So I'm going to create all the boilers that are in Pi. I want to create those in a table, and each one is in its own row. And if there's any updates, I want that row to be updated. So the way I'm going to do that is I'm going to base it off the element name in Pi, which if we went back and looked at the data set returned from Pi, this is one of the attributes. And I'm going to say create the table. So now I'm going to go to flows, and I'm going to say Pi boilers to SQL. And I'm going to grab the raw input that we set up from Pi, and I'm going to set the output to the SQL table. And I'm going to turn that on. And one of the new things in 2.3.2 is real-time status into the UI. And this is for flows. You'll see us add this for connections and other things to give you real-time feedback in terms of what's going on. Right now, everything looks good. The flow is running and executing. So if I bring up the SQL server, I've got a boilers table. If I do a select on there, what we should do, if I did this right, is we see a row for each one of the assets in Pi, right? Unique by element name, and all of the name value pairs in there. Right, we did that with very little configuration. We didn't use modeling in this case. We just kind of moved the data natively. So what I can do, I did this before the webinar, is I installed Tableau. And in just a few minutes, right, I set up a table that's based on boiler, and I can look at the fuel versus the fuel target and water versus the water target, and I can switch between boilers. And this took minutes, right, once the data was in SQL. So I went Pi to SQL, visualizing in Tableau. Now you could do this in Pi Vision. You could move the data into Influx. You could do a bunch. You could move it anywhere you want, but this is just a really good, clean example of how easy that is. All right, let's say we want that same data inside of our unified namespace. All right, so in that case, I'm going to use my local MQTT broker. So I have Mosquito installed locally. I'm going to use HiByte's MQTT connection. And this is default port. No security, everything. This is local. And what I'm going to do is create an output. And I'm going to create the output just like I kind of did before, called boilers. And I'm going to put it on a boilers topic to start. So I've created that new connection and output. And I'm going to take that existing flow. And all I'm going to do is I'm just going to add in MQTT. If I can get there, scroll down, looks like it made it. And I'm going to save it. I'm doing all this in real time. I'm not stopping and starting anything. And if I bring up my client, you'll see that I'm dumping this to the boilers topic. And if the data's there, right, it's an array of all the boilers, and yeah, that's great. But in terms of a UNS, it's not very structured, right? This isn't, what I really want is I want each boiler on its own topic. So this is a pretty cool new feature we added 223. So I'm gonna go into this output on MQTT. And the first thing I'm gonna do is add this breakup arrays. So we have an array of boiler objects coming in. I'm gonna actually break it up and publish each row of that array out individually. That on its own isn't that useful, right? Because I just turned one big publish into a bunch of little ones. But where it becomes really useful is when we start to use dynamic outputs. So I'm going to use this to take the data in each row and separate that into the namespace. So if we went and looked at the data coming from Pi, there's a plant attribute in there, right? So we're going to use that. And then the other one that was in there that we're familiar with is element name. And in real time, I'm going to save that. And like magic, you know, if I go back to auto scroll, you can see now what I'm doing is I'm breaking up each row and I'm sending it up over its own topic structure. So I'm starting to organize that namespace. And this could be, you know, depending on your naming convention, ISA 95, whatever you want. But this is pretty cool, right? So let me go back in. All right, let's move on to a new use case. So I can pull asset data out of Pi and I can move it into SQL. I can move it into my unified namespace. Let's combine some data. So let's do a little modeling. So I'm going to create a boiler status model. And in there, what I want to have is I want to have current, I'll call it, current status, but I also want events, right? So Pi has this concept of event frames. If you're familiar with Pi, it's a capture in time, kind of like an alert, and then it can capture like the state of the system of data in that event. So I want to combine those. So I've created a model to capture that. Now what I want to do is I need to go get the event data. I have the real-time data, or the current status, right? That's this one that we first created. But now I want to go create some events. So I'm going to call this B210 events. And we have the ability to read event frames. And I'm going to use the HiByte database. And at first, I'm going to query for everything. If you're in a production system, this probably doesn't make a lot of sense. It could be a huge query. I only have a few events over here. So in the JSON format, you can see an array of all the event frames in the system. And if I scroll down to the bottom, just as an example, you can see this is a fuel is low. And then there's an annotation on here that says fuel delivery showed up late, but at least it showed up, better late than never. Right, but in this case, I only want the ones related to the asset B210. So I can use Pi's syntax to do element name B210. And if I hit this read, you'll see this is only bringing back, you know, I went in and created an event for B210. So this is what I want. So I'm going to submit that. Now what I want to do is go create an instance, right? So I'm going to create a B210 status instance. And that's going to be based on the boiler status model. And in here, I'm going to wire up the two inputs. Now, I'm not doing a lot of detailed modeling here. This is kind of high level, you know, bringing the two modeled structures together. But what I can do is the B210 model, which I know brings back the current status. I'm going to drag the current status. And then the events, which I know brings back that event we were just looking at, I'm going to drag that over here. So I'm basically combining the two data sets. Now, where do I want it? Let's say I want it an ignition, right? I want that over in my SCADA system. I want to do some screens or whatever. So I'm going to send it over there using Sparkplug B, which is a protocol over MQTT. So you're going to see it's going to use the same Mosquitto broker that I used in my local MQTT connection. All that's the same. We're going to represent on the network will be a HiByte edge node and, oops, messed up. The group will be HiByte and let's do webinar because I'm super creative. Will be our edge node. And what we'll do is just create a simple output. We'll call it boilers just because that's what we call the others. And we won't have device ID or metric name. We'll just let it land under the edge of node. So let me go create a flow now that I have that all wired up. I'm going to do boiler status to Sparkplug B. And what I'm going to grab is the instance we just created, right? The current status, and then the output, just Sparkplug B. Turn it on. Cross my fingers, no errors. All right, and the one thing I think my ignition trial just ended. So I previously set up ignition. Let me had to sign in first to listen on that same local broker, right? And I enabled their MQTT engine to listen on Sparkplug, and that's all I had to do. It's minimal configuration in here. But now when I bring up the Ignition Designer here, oops, and I go to MQTT engine, edge of node, there's HiByte, there's webinar, there's B210 status, which was the instance name in HiByte. And if I expand this, and I think I have the transmitter on, so I think you're seeing it flash because I'm writing back in over the namespace. I got to look at this after to see why it's going bad quality and back. But you can see the update is coming in, the time's updating. This is the current status coming directly from Pi. And then under the actual event, you can see there's the event as well, right? Coming into the ignition system. And I think if I turn the transmitter off, I think I'll fix that. But I got a little work to do after. But you see how easy it was to push that entire structured data set out of Pi straight into my SCADA system. Pretty slick. All right, let's work on another one. So this is the use case kind of John was talking about around model training in terms of AI and ML. So what I want to do is go and create a model that's my boiler machine learning model, okay? And in here, what I'm going to do, this is going to be really simple, right? I'm going to have fuel, I'm going to have water, and I'm going to have a time of the sample. And let's say this is TensorFlow. I'm feeding this to somewhere that needs the data in this structure, right? So this is my model for my machine learning. So what I need to do is I need an historical data set to run through this model that I can use for training the system. And then I need the real-time data to be pumped through this model so I could feed it into ML to detect in real-time issues, right? So that historical data, I'm gonna actually grab both of those data sets from Pi. So the first thing I'm gonna do is go back into Pi, the connector, and I'm gonna create an input that is boiler ML. Let's remove the NL. The other thing we add in this release is you can rename objects that are referenced, which in previous releases, it would warn you. So in this case, if you mess up the naming, change it later, no big deal. We'll take care of it for you and rename all the references. It's pretty slick. All right, so I'm gonna do a point read this time. And I'm gonna go in and find some points. And in here, we support the Pi point query syntax. So I'm gonna look for anything with, starts with demo. And oh, look at that. I got 2 demo tags here for fuel and water. And if I just read the current value of those and we look over here, what you'll see is I've got the Pi points, right? The value and then the timestamp they were read, which the timestamps are the same because it's just the current value. But what I actually want, I want this to be historical data, right? So we could read averages over time, min, maxes, et cetera. But in this case, I want interpolated. So this uses a relative time syntax from Pi as well, right? So if you're familiar with the Pi system or the Pi documentation, you can find this. But I'm gonna say, oh, let's see, I'm gonna go from now back 12 hours, and this could be years, right? This I'm gonna do over a small data set, but you'll see how you could query a lot more data with this to current. The sample interval, I'm gonna have to be 5 minutes. So I want 5-minute samples over the past 12 hours. But let's say this is years and I actually wanna break that query up because it's too much data. So I actually wanna do it in 1-hour windows. So what this is doing is the first read, it's going to go through and grab, 12 hours ago, an hour's worth of data broken up into 5-minute measurements. And it's a little easier if you see it. Oh, I messed up my syntax. There we go. So you'll see that this is a UTC timestamp. So the timestamp is going to be a little different from my local system, but this is back 12 hours, right? Here's the 2 measurement points. And there should be, this is 5-minute samples over an hour. So I do the math. There's that many samples in there. And I'm doing a webinar, so I can't do that math. Maybe it's 20? No. John, you can help me out. All right. So I have that input defined, right?
12.
And thank you.
Yeah.
John's got me. So the other thing I'm going to do, I'm going to copy because I also need the current data, right? So I'm going to call this current, and I'm just going to copy the input, because the configuration is roughly the same. The only difference is I want the current value. And like we did before, that'll come back with the current. Oh, I didn't save it yet. So that this will come back with just the current values of the points. All right, so now I've got my data source mapped. I'm gonna go back to this model that I created and I'm gonna create 2 instances of it, okay? The first one I'm gonna create is B210 ML current. Okay, so this is the current, the most recent data. So I'm going to base it off the ML model, and the input I'm going to wire into it is the, I called it training currents. That's super confusing, right? So let me submit this work, and I'm going to go back and rename that to remove the training. Well, I guess I could have kept it, but I'm type A, and that would confuse me. So I'm going to go back. I got that instance current, and what I'm going to do is wire in the current data. So I'm going to expand this, and I've got my values for fuel, if I get this right, and my values for water. And then the timestamp on the current data is the same, so I could pull it from either, but I'm just going to fill out those values. Now I'm going to create a second instance. The second instance is the training instance, and the only difference is it's going to be wired up to different inputs, but based on the same model. And this is the key, right? Because as your models get more complex, you have to run the historical data and the current through the same one. So training, looks like I misspelled training, man. Wow, we could go fix that after too. So this is an array of data, right? This is the 12 samples. John, you did the math right, 9 + 3, 12. So I'm going to expand just the first one, right? I'm going to pull fuel over, water. I'm going to map the timestamp over. I'm going to submit that. And the key here is currently with this set to object, it's just going to read the first value in the row, right? But if I set this to array, it does what we call array expansion, which means I want to pass in all this historical data. You know, each sample is going to be run through the model, and out is going to become an array that's modeled after this and any kind of expression we want to write. So that's an important little feature there. All right, so I've got my inputs. I modeled it up. Now where am I going to send it? I'm going to send the current status up to AWS. So I'm going to create a connection to AWS IoT Core. And if I can, oops, sorry. The bar is in my way. So give me a second. There we go. So let's see, all I need is, I need this. I need the address of the broker. So I'm going to put that in. I'm going to put in, it's a secure connection, so 8883. All this is good, except I need to enable SSL. Before the webinar, I brought in the certificates, right? You can do that through the admin panel, but I'm just going to set them here. And this is for the secure connection and authentication. So let's submit that. And I'm going to create an input just to test this. I'm going to call it all. Save that. I'm going to do a test read. And this is going to hang for a second while I'm trying to, because there's no data yet. So I'm going to go to their test client up in AWS, and I'm going to publish all, and I'm just going to publish that test message, come back down to the HiByte. You can see that data landed in HiByte. So we know the connection's good, but I want to output, right? So I'm going to output boilers to the boilers topic, submit, and then I'm going to create a flow. Call it current status. And it's going to take the instance we created that's the current status based off the ML model, right? And it's going to output it to AWS. And we'll turn it on. And now if we jump out to AWS, and I apologize, I got to get around I don't know how to hide that banner. If I subscribe, just make sure that works. Yep. So if I subscribe, we'll see the data starting to come in, and I think it was. Let me refresh the. Oh, there we go. I wasn't on the. There we go. So you can see this data is changing one side. So this is the current data, right? And I could feed this into TensorFlow or AWS or whatever I want to use for machine learning. That might detect an error and send it back down to the plant. But what I got to do is get the training data. And the training data, I don't want to send up to AWS because it's expensive, right? It could be a lot of data. So I'm going to create a CSV connection. All right, CSV. And I'm going to dump this to my local drive. And I'm going to create an output that is boiler training. CSV. And I want to create that file. I got to remember to do that. So I'm going to go create another flow that's boiler ML training. Right? And I'm going to grab the instance that we wired up with the historical data, and we're going to output that to the CSV file. And what this is going to do is chew through in those chunks of 1 hour, 12 hours ago. And what we'll see is this will run for a little bit, and then it'll come up in an error state because there's no more data. In 2.3, we remove the error state for no data because it is a common thing you can run into, and you don't want to, mistakenly think that's an error. So that part will go away, but the functionality will remain the same. So you can see no more data. So I'm just going to turn it off. And now if we jump out to the drive, there's that CSV file, and this contains all the historical data, fuel, water, based on the same model. From Pi, right? And then I can back all this into my ML training or however I want to get this up to train the model, I can do it. So that's pretty cool. The key there is I ran it through the same data model, right? Which is really important because whatever ML engine you're using is going to expect that. All right, we're almost running out of time, but I got 2 more. I want to show getting data back into Pi, right? And so there's 2 things I want to do. The first, I'm going to go pretty quick because we've done this one before. I'm going to connect into OPC UA. I've got Kepware running locally. 49.320. I'm using default credentials. We have the browsability, so I'm going to jump in, and in here I've got a B210 motor model. So I'm going to bring in 3 tags on that: amps, vibration, and volts. All right, so I'm going to go create a model. I'm going to call it motor, and it's going to have amps. It's going to have vibration, and it's going to have volts. And you could probably guess it by now, but I'm going to create an instance of that model for B210. I'm going to call it the B210 motor. And in there, I am going to base it off the motor model, and then OPC. I'm going to bring over amps, vibration, volts. Pretty basic, right? Now I want to get that into Pi, right? And this is where it gets really cool. So I've got a few seconds here. Let me show you Influx too. So Influx we used to be able to do via REST. Now it's got its own connector. So I'm going to send it to Pi and Influx. I've got Influx running locally on a Docker container. Here. So I think the port is 8086. And the only thing I need really is the token. So let me just copy that while I'm here. So I got the token. I got to put the port on here, 8086. Organization name, if you're running it in Docker, it does require one to set up on the setup. So I'm going to set that to HiByte. And I'm going to create a real quick output. And I'm going to output it. I'm just going to output motors. I'm going to output it to a HiByte bucket, which I have. That's basically their equivalent kind of a table. And I could tag it. So I could do things like plant equal to this stuff like we saw before, right? And this would help organize it at Influx, but I'm not going to do that for this demo. So I've got my Influx output. The other output I want to create is Pi. So I'm going to jump into Pi, and I'm going to create an output that's an asset, right? I'm going to call it motors. I'm going to write to the HiByte database. And since I'm writing an asset, it's going to write the Pi points and the asset and the template from HiByte, so all 3. But I need a path, so I don't want to land it in the root because that there's no context there. I actually want to land it under B210. So what I'm going to go is copy that path, and then I don't need the front end of it, the HiByte and the machine name. I just need this. The asset name is going to be by default the instance name in HiByte. The timestamp, you could override the timestamp that's used on the point write, so we're not going to do that. We're just going to leave that by default. All right. Now we're going to create a flow, right? So we're going to say motor data to time series or something like that. And we're going to go grab that motor instance, B210 motor, and we're going to output it both to Influx and to OSI soft. And cross my finger. Now this will work. All right, so we're not getting any errors. So if I jump to Influx and I go into their data explorer, we have Influx inputs too, which is really cool. but let's go back to the query builder. You can see HiByte, the motor, the attributes, B210 motor, and if I submit, you can see this data is coming in. Now you can take this script, the Flux script, and put it back to read the data back out, and you can do aggregates, a bunch of cool stuff. But unfortunately, we don't have time to see that today. But also, so if I jump out to Pi, it didn't go where I wanted it. So let's see if it landed. Let's go troubleshoot real quick. Oh, I know I'm getting errors, I bet. I didn't set it to create. Let's see. Aha, you got to hit the button. So we'll write to an asset that's there. By default, we won't go create and mess with your Pi system. But if you tell us to, all bets are off. So let me go back and refresh this. And you'll see the B210 motor instance shows up. The model shows up. The attributes show up. This is updating in real time. And we can go look at the template. The very last thing I want to see you see with 2 minutes left, this is kind of this is pretty cool. I am going to go define. So let's say the ML thing, did some training. The current status was sent up. AWS found something was wrong and it wanted to send something back down. Like, you need to fix this. So what I'm going to do is create an input here, which I already did, but I'm going to call this alert. I'm going to listen in on the alert topic. Submit this and read. I'm going to jump up to AWS and I'm going to publish on the alert topic a message that says, whoa, this is cool. All right, we're going to publish that down. As before, the magic, there it is in HiByte. I'm going to create a flow that, actually, I'm going to hijack the flow I already have, the time series flow. And I'm going to take that input, which is the AWS input we just defined, which is the alert, and I'm going to pipe that out to Pi. And I'm doing this all in real time. I didn't stop any flows, right? Now, if I jump into the Pi system and I hit refresh, you'll see a value appears. Value is because we didn't assign it to an instance. So this is just the default name it got. It says, whoa, this is cool. And just to prove that that's working, the very last part of the demo, we go, this is really cool. And we publish that and go refresh. How cool is that? All right, demos. I know I ran a little over there. Apologize, John, and everyone else
nice job.
Who watched. I know we went really fast, but pretty awesome stuff. So hopefully get you thinking.
No, that was tremendous, Aaron. And one of these days, we're just going to start counting the number of connections and flows that you show and keep a running tally of it. Last thing I wanted to talk about before we get into Q&A, we are making some changes to our pricing and packaging as a result of all these new capabilities that we've added in. We've renamed them from the single instance and site license to standard and professional. They generally have the same functionality as before, the same price. The Pi connector is part of the professional license because it's really multiple components to it. So we've put that in the professional license. We also highlight that, of course, we've got redundancy that we added a couple of releases ago. We've got multi-hub management, so you can have a dev and a test and production server. But just wanted to get this in front of people before we, because it is something that we're rolling out as part of this release. At this point, we want to turn it over to Q&A. But first, I just want to thank Aaron. I mean, he just crushed it. He showed a ton of functionality. And I'll say for myself, as well as probably some of the other people on this, he went really fast. The beauty is it's all recorded. So if you want to watch it again, you want to just skip to a section that you saw, just do that and you can watch it again. You can see how it happened, because now that you know what you're looking for, all the different components that he showed, feel free to go to our YouTube channel in another day or two, or you'll get the recording and jump to the section that you want to see and re-watch it, and you'll be able to see how he did it. Because as he said, everything was done in real time in his demo. So thanks a lot, Aaron. That was awesome. Tori, I think the ball's in your court to ask us some questions.
Sounds good. And I will, I'll reiterate that it was really, really cool, Aaron.
I'm going to launch one more poll before we jump into that too. really quick. So we added this connection to historians. We focused on the OSI Pi historian. We do have connection to most of the other historians in this list, and but we're interested in who's using what, and we're also, interested in if people are struggling with integrating with these systems, feel free to reach out to us, because there are connection points to all of them, and we'd be happy to look into that and work with you on that. I will end the poll and go ahead.
I was just gonna say, while everyone's responding to that, actually it's along the same line. So we did have a question about moving data from Wonderware Historian into Google Cloud Platform. I think the short answer there is yes, but Aaron, John, did you wanna maybe speak a little bit more on how to do that?
Yeah, so today with Google, we support PubSub, their PubSub connector, not their IoT Core connector. IoT Core is on our radar. We actually got asked about it the other day as well. So that's when we could add. In terms of Wonderware in SQL, their data format's a little different in terms of how they store it in SQL, but I believe, although I haven't tried it, you could use our JDBC connector to get into it, or just our SQL connector with some formatting, since it's so flexible. What you'll see is like our story before with Pi was you can connect over REST or JDBC. What you'll see is we create native connectors for these more common historians, and you kind of see the power of that once we do it. So, Wonderware in SQL could be another one of those, as well as GE Prophecy and some others.
Great. I have another question for you. So earlier we saw you publish data into a CSV for machine learning training. What about moving that CSV to S3? Is that capable now or on the roadmap?
So you can. So you can't currently, what you can't do right now is drop the whole file into S3. So that is on the roadmap, kind of file transfer and also an S3 connector. So I think right now that's 2.4, John, I think, or 2, yeah, I think 2.4
Yep.
for S3. But we're very aware of that use case. We're being asked a lot for file transfer, not necessarily even CSV, and S3 is the landing spot in the AWS side for that. So you will see support for that in the upcoming releases.
Great.
If people have needs around file transfer, please reach out to Aaron or myself. We're interested in better understanding those needs. We've talked to some of our customers who are looking for it, but just trying to do some market research. So please reach out.
John, we also got a couple questions on the licensing, particularly around the Pi agent. Maybe you could just cut back the slide before and maybe cover that again one more time about exactly how this is packaged and how can users access the Pi agent?
Yeah, so the Pi agent is part of our professional license. So the Pi agent is a second, as Aaron explained, there's the hub, and then there's an agent capability. And so we decided that's really, two components, part of the professional license. And in that, you'll also be able to deploy, as many hubs as you want within a site. You can do dev and test and production site hubs. So that would be covered in the professional license. All the other connectors are part of our standard license.
And you can trial the Pi connector too, right? So that's
available. Yeah, absolutely. And it's also part of our enterprise license. So it's, the enterprise license would also include that. So
that's great. I think we've covered about everything else, gone through and answered a few questions in text. So I'll just give everyone one more minute if they have any lingering questions. Otherwise, of course, feel free to shoot us a note too at either info@highbyte.com or sales@highbyte.com. Great. There's an interesting question. Aaron, I don't know if you can see it right now in the Q&A. OSI Pi Asset Framework is a strong tool for UNS definition. How does the UNS live side by side with OSI Pi Asset Framework structure?
Yeah, so I think it's a great, if as an organization, you put a lot of effort into AF and structuring your data there, I think you want to leverage that in your UNS, right? You don't want to have to copy that. And hopefully, kind of what I showed you gives you an idea with that HighByte agent in our connector how you can do that, right? You can take that data straight out of AF, structured the hierarchy and everything, and publish that into either Sparkplug B or MQTT. You can further partition it in namespaces. So I think the answer to that is it's bidirectional, right? Like ideally, the whole ecosystem of products can publish into the UNS and pull out of it as well, kind of like I showed you with Ignition, right? If I publish into the UNS, it just shows up in Ignition. And I think that's the future of where the space is headed. And I think Pi would fit that as well.
Yeah, so what you were showing, Aaron, was you can set up a query so that if a new asset shows up in Asset Framework, we'll pull that data, instantly push it directly into the UNS. Right. So that it's just in real time, constantly checking and publishing whatever's there in all the real-time values.
Yep. Yeah, exactly.
With this structure that Pi has, without having to restructure it in HighByte. If it's already structured exactly as you want, just keep on pushing.
Right. Yep.
Great. Awesome.
All right, one just piece of housekeeping before we let everyone go is we'll send out the deck and a recording of the presentation in the next 24 hours by email. So be looking for that. And again, reach out at sales@highbyte.com if you have any questions, or you can contact John and Aaron directly.
Thank you all for joining us. We appreciate your time. Have a good day.
Cheers.
Bye.